Have you ever felt like a magician in math class? You know, you're solving for x, you wave your pencil, and numbers just magically jump from one side of an equation to the other? Well, today, we're going to pull back the curtain on that exact trick. It's one you've probably done 1,000 times, but do you know the real secret behind it? Let's find out.
I'm sure this sounds familiar. Your teacher says something like, okay, to solve this, just move the number to the other side of the equal sign, and don't forget to flip the sign. It's a rule we all learned, we memorized it, and hey, it works.
But did you ever stop and think, why? I mean, really, why does a +5 suddenly become a -5 just because it crossed a little equal sign? Is it some kind of mathematical voodoo? Is it actual magic? Well, spoiler alert, it's not. And today, we're going to expose the entire illusion.
So, here's our game plan for cracking the code. First, we'll look at the trick itself, what I like to call the magic portal. Then we'll uncover the real secret, keeping the balance. After that, we'll practice with some apples and bananas, look at how the magic can go wrong, and finally, put it all together to solve for the great unknown. All right, let's get into it. Every great magic show starts with, the performance of the trick. So first, let's just watch the classic move in action. This is the how. This is the part you probably already know how to do.
But before we do that, we need to talk about our main prop, the equation itself. So what is an equation? Really, it's just a statement saying two things are equal. And the best way to picture this, and you gotta remember this, is to think of a perfectly balanced scale. What's on the left side weighs exactly the same as what's on the right. This idea is everything.
Okay, abracadabra, watch closely. We've got 3x plus 5 equals 20. We want to get that x all by itself, so we do the trick. We take that +5, it takes a leap of faith across the equal sign, our little magic portal, and poof, it's now a -5 on the other side, like magic. Or is it? And now, for my next act, the big reveal. This is the part where the magician finally shows you how the trick is really done. We are pulling back the curtain to see the simple, kind of beautiful logic that makes this whole magic portal thing work. This, my friends, is the why. Here it is, the one single golden rule of algebra. This is the secret sauce. If you do the same operation to both sides of an equation, it remains the same. It's all about one thing, maintaining that perfect balance. That's it. That's the whole game. So here's the secret. We're not actually moving anything. Think about our scale. Our goal is to get the x all alone, right? So to get rid of that +5 on the left, we have to do its opposite. We subtract 5. But whoa, hold on. If we just take 5 off the left side, our scale is going to tip. It's not balanced anymore. So to fix it, we have to do the exact same thing to the other side. We subtract 5 from the right, and just like that, the scale is perfectly balanced again. Now check this out. This lays the whole thing bare. On the left, you've got the illusion, the magic portal method. On the right, you have the reality, the balance rule. But look closely. The magic trick is just a shortcut. When you subtract 5 from both sides, the +5 and -5 on the left just cancel each other out. And what are you left with? Just a -5 on the right. See, it's not magic at all. It's just efficiency.
Okay, so now you know the secret. You've seen behind the curtain. Now we can start really mastering this craft, and that means learning how to handle equations with a few more moving parts. And for that, believe it or not, we're going to need to talk about some apples and bananas.
It's a fundamental truth, right? Not just in the grocery store, but in algebra too. You can't add apples and bananas. I mean, if you have 3 bananas and 4 apples, you don't have 7 Bane apples. You just have 3 bananas and 4 apples. In algebra, we call these like terms. You can only combine things that are the same kind of thing. So how does this help us with a bigger equation? Well, just imagine our x terms are the apples, and the plain old numbers are the bananas. The goal is always the same. Get all your apples on one side of the scale and all your bananas on the other. And we use our new favorite tool, the balance rule, to do it, making sure that scale stays perfectly level the whole time.
Knowing how a magic trick works is one thing, but performing it perfectly every time, that's another. Even the best magicians mess up sometimes. In algebra, we call these little mistakes magical misfires, and they usually happen when we forget the simple logic behind the trick.
So here are the most common ways this trick can blow up in your face. First up, the big one, forgetting to flip the sign. That's like taking weight off just one side of the scale and walking away. The balance is totally broken. Next, trying to add apples and bananas, like trying to combine 3x and 4. They're not like terms. And finally, a simple but deadly one, just copying the problem down wrong. I mean, the best magician in the world can't do a card trick if they start with the wrong cards.
All right, it is time for the grand finale. We've learned the trick, we've peeked behind the curtain to see the secret, and we know the traps to avoid. So now, let's put it all together and solve for the unknown, from start to finish.
So here's your 5-step playbook for pretty much any of these equations. Step 1, simplify. Just tidy up each side by combining any like terms you see. Steps 2 and 3, gather. Use that balance rule to get all your x terms on one side and all the numbers on the other. Step 4, simplify again. Tidy up one more time. And now for the final reveal, step 5, isolate x. All you do is divide both sides by the number attached to the x, and voila, the unknown is revealed.
So there you have it. That magic portal was never really magic at all. It was just a really slick shortcut for a simple but super powerful idea, keeping the equation in balance. Which kind of leaves us with one last question to chew on. Now that you know the secret behind this trick, what other math rules that you just memorized in school might also be clever shortcuts for a much deeper, cooler idea? It really makes you think, doesn't it? Thanks for watching.